Welcome everybody. Welcome to the last lecture of the year 2022. Okay, so we'll be meeting next year. So let us now begin this chapter 7. Chapter 7 is on set relations and functions. Good afternoon, Yashraj, Sindhu, Pratibha, Lovepreet, Aryan, Ananya, Soumyarajan, Manish, Nikita, Sherry, Bharat, Ritu. Okay, yes, thank you for your New Year wishes also. Yes, thank you so much. Okay, so let us. See, the first time we heard about set was when we got a geometry box. It was a set of all the instruments that you need for drawing that we use in geometry. Okay, so that was your set box. Then that is the first time when you hear that. What that means is that it is a collection of well-defined and distinct objects. Okay, you will never hear a set of water. Okay, you need to have objects which are well-defined and which are distinct. Okay, the set in mathematics is represented by a capital letter, and all the elements inside that set is represented by small letter. Okay, that is the convention. You may have set which may contain finite or infinite elements. Okay, so stars in the sky, so that is infinite. But if I'm talking about even numbers less than 20, then that is a finite set. Then it is also, set is represented in two forms. One is called as the rooster method and the second is called as the set builder form. When all the elements are listed out, okay, so listed out, that is, I'm writing down all the elements, then it is called as the rooster form. Most of the times we are using this because the number of elements are finite, and when we are using this, when we are using sums to solve, those are small sums for our MCQ, so usually we're using the rooster form. But having said that, we also use the set builder form. So when the properties satisfied by the elements are listed out, so when we are, I think the grammar is incorrect. When we are talking, representing the property instead of the actual elements, then we are saying it is a set builder form. That is how we are building the set. Okay. For example, when I'm saying less than 20, odd numbers or even numbers, so what I'm defining is the property. Okay, whether it's an even, whether it's odd. For example, here we are taking, let x is such that x is equal to m being an integer lying in the interval 0 to 6. So in my number line, this is my 6 and this is my 0. So what will A contain? A will contain 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Okay, lying between this is important. M is greater than 0, so 0 will not come, and M is less than 6, so 6 is also not there. So what will my A be? Set A. This is my set builder form. And how do I write it in the rooster form? It is 1, 2, 3, 4, 5. This is important that I'm using only these because it has already been defined that M is an integer. Okay. So these are the two ways in which you can represent a set. So what is a set? Set is a collection of well-defined distinct objects. And how do I represent it? I can represent it by the rooster method or the set builder form. Then there are different types of sets that we are going to talk about. This is called as phi. It's a Greek alphabet. It is simply, I write an O and then I put a line in between. So it is called as a null set. It is a set with no elements. Okay. Please remember, if I have something like this is not phi. Okay. This is a set with 0 as an element. Okay. So equal sets, when two sets A and B are said to be equal, if every element of A is present in B and every element of B is present in A. So this AND is also very important, and it is represented by A is equal to B. So suppose I have A as 1, 2, 3 and B as 1, 2, 3, 4. Then all elements of A are in B. Okay, 1, 2, 3. But are all elements in B in A? No. So A is not equal to B. But if I have A also as 1, 2, 3 and B also as 1, 2, 3, then I say A is equal to B. Okay. So we have talked about null set. We have talked about equal set. Another very important concept is the equivalent set. When the number of elements of A and is equal to the number of elements of B, then we say they are equivalent sets. Okay. So A is equal to 1, 2, 3 and B is equal to ABC. So equivalence sets. Okay. Then what is known as singleton set. A set containing only one element is called a singleton set. Okay, so one element is singleton. Universal set, it is a set containing all the elements of the question. So that suppose I have, let us take this example. I have this as universal set is given by 2, 4, 6, 7, 8, 10. Then from this, suppose I want to find out X, the set is such that X is such that X is an even number. Okay. Then in this case, what will be the numbers? 2, 4, 8 and 10. So this is the set which is containing all the elements. Okay. Now, how do I represent a set? It is represented in curly brackets and all the elements are written in small letters and the set is represented by capital letters. Now, what does this E sign look? It means element belongs to set. Okay, so when I write like this, it means X belongs to B. Now, this sign, okay, this is like an U which is inverted, not completely 90-degree inverted. So A is a proper subset of B. So the word is proper. Okay, we are going to talk about what is proper and what is improper. And when I have this with a line under it, it is A is a subset of B. It means A may be a subset or improper or proper subset of B. Then when I'm writing U, it represents union. Okay, and when I'm writing inverted U, it represents intersection. Okay, so these are the important symbols that we are using in the chapter on sets. Then complement of a set. For suppose I have my universal set to be equal to 1, 2, 3, 4 and 5. And my A is equal to 2 and 5. Okay. Then my A complement, okay, this word complement, it is represented like this, okay, is equal to what? All the elements in the universal set which are not present in A. So 1 is not present in A. So which are not present in A? Let me show. This is not present in A. This is present. This is not present. This is not present. Okay. So I will write this as 1, 3 and 4. So A is given. Then how do I find A complement? All the elements in the universal set which are not present in A. Then we have A minus B. It is a set which contains all the elements of A which are not present in B. Okay. So here Suppose I have A to be equal to 2, 5 and B suppose is equal to 1, 2, 3, 4, 5. Then in this case, A minus B is how much? Not 5 here. 1, 2, 3, 4, 6. Then is 2 present in B? Yes. Is 5 present in B? No. Then A minus B will be equal to 6. Okay. What about B minus A? Okay. Can I find out that? All elements of B which are not present in A. Is 1 present in A? No. So I'll write that. 2 present in A? Yes. I will not write that. 3, it's not present. 4, it's not present. And 6, it is not present. Okay. So A minus B is always an element of A which is not present in B. This is an important property which you can even get for theory question. A minus B is always a subset of A. And B minus A is a set which contains all elements of B which are not present in A. So B minus A is always a subset of B. Okay, sorry about this. This is B. Okay. Then we have the concept of cardinal number. So number of elements in a given finite set is known as A. So if I have A to be equal to 1, 2, 3, then N of A is called as a cardinal set is equal to 3. What if B is equal to 2, 4, 6, 8, 10? Then N of B is equal to 1, 2, 3, 4, 5. N of B is equal to 5. Okay. So are you following till now? Thank you, Yash Raj. Thank you. You like the teaching. Yes, Ritu. Happy New Year in advance. Tamanna, can you hear my voice now? Yeah. Yes, Nikita. This is a null set. Okay. All these are null set. Very good, Siddhartha. Dimple, yes. Okay, Ritu. Anmol, yes, you have theory question where you will be given the option. Okay, they will ask you which of this is true, and that is this true that A minus B is a subset of A. You know, that type of question. You don't have to write. Theory doesn't mean you have to write. Just you don't have to solve sums. Only concept you should know. Okay, A minus B means what? Suppose I consider this. This is my A and this is my B. A minus B. I check all these. Okay, I check whether all the elements of A, whether they are present in B. If they are present in B, I will not write. If they are not present in B, I will write. Like let us check 1. 1, whether it's present in B? No. So I will write it. 2, is it present in B? Yes. So I will not write it. Then 3, is it present in B? No. So I will write it. And there are no other elements. So this is A minus B. Let us see B minus A. Let us check whether elements in B are present in A. 2. Yes, it is present in A. So I will not write it. Then 4. No. So 4, 6, 8, 10. These are elements in B not present in A. What does it simply means? Whatever common elements are there, don't write them and then write down the remaining elements. Okay, Ritu, I hope you've understood. Yes, Amina, clear? Siddharth, you can watch this video again. Okay, if you want, you take down notes. now, or you can even do that. After that, you go to YouTube, just put in ICI YouTube channel, and there you will find all these videos. Alpithankar, yes, sets is very important, because right now also you need to know how to solve problems. Statistics, the whole base of statistics comes from sets. Okay, you're trying to understand. Then you want to group things together which have same properties together. Okay, that also you do. So this is easier. Okay. Yes, Tamanna, good, you can hear now. Yes. Yes, Ritu, welcome. Now, what is a subset? If every element of set P is also present in set Q, then we say P is a subset of Q. If every element of one set is present in the other set, then we say that first set is a subset of the other set. Also, if all the elements of P are present in Q, then we say that it is a proper subset of Q. So if a set is like here, now P contains 1, 2 and Q contains 1, 2, 3, 4. So all the elements of P, whether they are present in Q, 1, yes, it is present. 2, it is present. Any other? No. So then we say P is a proper subset of Q. Okay. Also, if a set has n elements, this is also very important. You may get a small sum on it also, and you may get it as a property also. If a set has n elements, it has 2 raised to n subset. Also, it has 2 raised to n minus 1 proper subset. Okay, we'll be doing that later, but this property you should know. So if like in this case, how much is n of P? How many elements are there? 1 and 2. So this is 2. So how many? So subsets of P. How many subsets of P are there? This is equal to 2 raised to 2, which is equal to 4 subsets. And how many proper subsets? Proper subsets will be 2 raised to 2 minus 1, which is equal to 4 minus 1, which is equal to 3. Okay. Now let us see here what will be the subsets. This will be equal to null. Then you have 1, you have 2, and you have 1, 2. Okay. 1, 2, 3, 4. Okay. So there are 4 subsets. These are subsets of P. And what will be the proper subset? Null set 1 and 2 will be the proper subset, because there all the elements of P are present in Q. Let us take this example. A is equal to 1, 2, 3. Then how many subsets? We know number of subsets is equal to 2 raised to n. So 2 raised to, how many elements are there? 1, 2 and 3. So 2 raised to 3, which is equal to 8. And what are those subsets? 1, 2, 3, 1, 2, 1, 3, 2, 3, null set, and 1, 2, 3. Okay. So all you have to do is write down all the elements. First you will write them singly, then you will write them in pairs, and then you will write down in group of 3, and so on. Okay. So power set. And what is this called? This is called as the power set. Okay, this is called as the power set. Power set is a set containing all the sets that can be formed from the given set. So what is power set? It is a set of all the sets which can be formed using the given set. So power set, it is a collection of all possible subsets of a given set, is called as a power set. A set containing n elements has 2 raised to n subset. A set containing n elements has 2 raised to n minus 1 power subset. Then a very important thing is called as the ordered pair. 2 elements A and B listed in a specific order form an ordered pair denoted by AN. A comma B. Okay, suppose I have A as 1, 2, 3, and if I have B as 2, 3, okay, let me take them other numbers. 4, 5. Then I have A cross B to be equal to 1, 4, 1, 5, 2, 4, 2, 5, 3, 4, and 3, 5. Then this is called as a ordered pair. Why is it ordered? Because the way in which it is written is very important. Because this one, the first element, is coming from which set? A. What about the second element? It is coming from B. Can I interchange it? No. Because if I write it as 4, 1, is 4 present in the set A? No. So what happens here is we are writing it in an ordered pair where the order is specific or specified. So I have to use it that way. Okay. Then we are going to talk about intersection and union of sets. Okay, I'm just telling you all the concepts so that once we have all the names and concepts in our mind, when we start solving the sums, you will understand it better. Proper subset is a type of subset. Okay, Anmol? Yes, Ritu, right. Ankur, you can start preparing from now. Okay, Shubhasya Shigram. So you can do it round. Already videos of this batch are present, so you can watch those also, and you can start your studies. Okay. Now we have the concept of intersection of set and union of set. As you can understand, when we are talking of union, what happens? You have two things, you bring them together. Okay, you have two things and you bring them together. So what will happen when I have two sets A and B? When I bring them together, I will have a bigger set containing all the elements of A and B. But it is very important in sets that you do not repeat the numbers. Okay, if I am writing one number from one set, I will not write it again for the second set. Once I've written it over there once, it is going to be there. Okay, I cannot have something like this. Okay, okay, that will not happen. You will have only this. So similarly, intersection. What is intersection? If I have two sets A and B, then the intersection of this set is written by this, and it will contain all elements, very important to understand, which are common to both A and B. Okay, the important word is common. Okay. Now let us take this example. A is 2, 4, 6, 8, 10 and B is 4, 6, 7. Is 2 present here? No. So I will not write it in intersection. Is 4 present here? Yes. So A intersection B is 4. Now 6. Whether 6 is present? Yes. So I will write down 6. 8. Whether it's present? No. 10? No. So A intersection B will be 4, 6. Now let us take C, which is equal to 5, 7, 9. Then I will write A intersection C. Now 2. Is it present? No. 4. No. 6. 8. 10. No. There are no common elements between A and C. Then what will be A intersection C? It will be a null set, which you can write it like this. Okay. So when I have common elements between two sets, I will write them down. That will be my A intersection B. And if I don't have any common numbers, I will write it as null set. Okay. Like I was telling you, A and B. When I want to find the union, means what? All elements of A and B, I'm going to write them together. All elements of A and B, I'm going to write them. But if there are any common elements, I'm not going to write them only once. So 2, is it present here? 2 I will write down. 4 I will write down. Then 6 I will write down. 8 and 10. Okay. I've written down all the elements of A. Then I will write down elements of B. 4, I have already written, so I will not write it again. 6, I have already written, I will not write it. 7, is it present over here? No, so I will write it down. So what is A union B? 2, 4, 6, 8, 10 and 7. I wrote down all the elements of A and then I started seeing what are the elements of B which are not present. Those I will write down. But see, here you can see 2, 4, 6, 8, 10, 7. It is a convention that you will write it in either the ascending or the descending order. So I will rearrange this and write it as 2, 4, 6, 7, 8 and 10. Okay, is that clear? So this is how I'm going to write down union. So intersection is what? Here I will also show you. A intersection B is, I'm going to write down only the common elements. In this case it is 4, 6. And here I'm writing the union means all the elements of both the sets. Yes, Ritu. Today's chapter is very interesting. Now, what is known as symmetric difference? The set of elements which are present in exactly one of the sets. So, I have A intersection A, symmetric B is equal to A union B upon A intersection B. Now, first I will find out what is A union B. So, what is A union B? I will write down all the elements of set A, 2, 4, 6. But then 7 is here. So I will write down 7, 8, 10. And what are the elements of A intersection B? 4 and 6. Okay. So what will be the symmetric difference? The set of elements which are present in exactly one means what? Which is present on only one set, not both the set. So what will I have over here? 2, 7, 8, 10. Okay, so you can see from here, 2 is present in which set? It is present in A. Is it present in B? No. 7, it is present in B. 8, it is present in A. And 10, it is present in A. Okay, so this is what is symmetric difference. Now, this is called as the Cartesian product. Okay, A cross B, which I've shown you earlier, this is called known as Cartesian product. So, if A and B are two non-empty sets, then this, when we said this is an ordered pair. Okay, ordered pair. How is it represented? A cross B is all the elements of A cross B, AB are such that A belongs to A. This dot means what? Such that A belongs to element A belongs to set A and element B belongs to set B. Okay. If either of the sets is a null set, then A cross B will be a null set also. If either of the sets is a null set, then A cross B will be a null set. Now here A is equal to 1, 2, 3 and B is equal to 4, 5, then A cross B. What did I tell you that time? First element will be from set A and second element will be from set B. Now I take the first element. What is that? 1. Whom I am going to pair it with? All the elements of B. So 1, 4. Then the second ordered pair will be again 1, 5. Okay. Then let me take the second element of set A, that is 2. 2, 4 and 2, 2, 4 and 2, 5. Then 3, 4 and 3, 5. Okay. Three, 4 and 3, 5 will be the Cartesian product. Okay. So this is one way. The second thing they may ask you is they will give you A cross B and then they will ask you to find out the two sets A and B. Okay. Like for this, we have written it down. Okay. Yeah. Now, if they've already given you A cross B and they're asking you to find the set A and the set B, what you have to remember is that first element will go to set A and second element will go to set B. What is this 3, 2? Where will this 3 go? It will go to A and this is going to go to B. This will go to set A. This will go to set B. Set A, set B. Set A and set B. Okay, so 3 from the first, this from this 3 and this goes here 2. Then here 3 and 4. But I don't repeat. Okay, so I've written 3. I will not write it again. But 4, I will write it over here. And then 5. Okay, there is nothing else. So this is 3, 5, 2, 4. 1, 2, 3, 4. So this is the correct answer. Is that clear to everyone? Just let me know. And these are very easy marks that you can get, you know, there are no calculation. You just have to be patient. You have to be careful. That's all it is needed. You have to be like sometimes, you know, you see such simple sums and then you get overexcited and you may become careless. So that should not happen. Here you can see there are 4 elements in A cross B. So I will see how I can write it. So I can see that 3 is repeated. 3, 2, 3, 4, so I will write it 3 once. Then 5, 2, 5, 4, I will write 5 once. Okay, and so on. Mangilal, only common should be taken from both A and B. Yes, whenever you are, it's being repeated, you are going to write it 1. And when we are talking about intersection, you are going to take common elements only. Okay, intersection, that is which are the elements which are present in A as well as B, that you will write down. Okay. No, it is ascending is not must. You can write it in descending also. And also there is no rule saying that you have to write it like this, but it becomes easier for us to even solve it also. Non-empty, rubbish, non-empty means when there is something in it. Empty means what? Which is empty, मतलब जो खाली है उसको empty बोलते हैं और जो खाली नहीं है उसको non-empty बोलते हैं. Okay. Yes, good. Manish has understood. Surya, Arudhya, Ashutosh, Ritu, Dimple, Yashraj, Aryan, Ankur, and Tanmeet. Very good. Okay. So let us go to the next. This is very important. You get a lot of sums in De Morgan's law. Okay. You don't have to go into how it is found out, etc. Okay. Then this is De Morgan's, and you also should know Venn diagram. Okay, so we are going to do that. Venn diagram is nothing but we are going to represent the elements of the set in terms of a circle. Okay, in terms of diagrammatic representation. Now, for example, let us see that the set A is given like this: 0, 1, 2, 3 up to 9. set P is given and set Q is given. Now, what does the De Morgan law say? That P union Q, okay? And if I want to find the complement, this is equal to P dash intersection Q dash. And opposite will also apply. If I have P intersection Q complement, this is equal to P dash union Q dash. Okay. So now, how do I first? We will see it by example that whether this holds or not. Okay. Now I have P and I have Q. Let us first talk about the LHS of equation 1. Okay. This is equation 1 and this is equation 2. Now what is LHS P union Q? First I will find out P union Q and then I will find out the complement. What is complement? Complement is all the elements of the universal set which are not present in the given set. All the elements of the universal set which are not present in the given set. So let us find out first P union Q. What is P union Q? Is all the sets of all the elements of set P and Q. P union Q is all the elements of set P and Q, but remember that all the common elements will be written only once. So here, what is P? 0, 2, 4, 6, 8. What is Q? 1, 2, 3, 4, 5. So I am whatever common element. So see 2 is common. So I will just put a small cross. 4 is common. I will just put a small cross. So what do I have? Whatever remains, I will write it down. So P union Q will be equal to 0, 1, 2, 3, 4, 6, 8. Okay. P union Q is 0, 1, 2, 3, 4, 6, 8. Now what is my this thing? Universal set 0, 1, 2, 3 up to 9. Now P union Q complement means what? All the elements in the universal set which are not present in P union Q. So all the elements of P union Q, I will cross it. 0, I will cross it here. 1, 2, 3, 4. Now this is 6 and 8. So 6 and 8. So what are the elements which are remaining in the universal set? I'm going to write it down. So what are this? 5, 7, 9. So 5, 7, 9. Oh, 5 I have missed it over here. Okay, not 5 here. Okay, so this is 7 and 9. Okay. So I will show it to you again so that you get a better understanding. So here what I do is okay. So first what I do, P union Q. So all the common elements, I will just cross it. So 0, 1, 0 is present? No. 2? Yes. So I will cross it. 4 is present? Yes. I will cross it. So whatever remaining elements are there, I'm going to write it down. So what am I going to write down in P union Q? 0, then 1, then 2, then 3, then 4, then 5, 6, and 8. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 elements in P union Q. Okay. Now what about P union Q? Complement is all the elements in the universal set which are not present in P union Q. So all these elements I'm going to just strike it off. So 0, 1, 2, 3, 4, 5, 6, and 8. So what are the elements that remain? It is 7 and 9. So 7 and 9 will be P union Q complement. Okay. Now let us see this P complement intersection. So RHS. Now let us see RHS of equation 1. Now first I need to find P dash. What is P dash? P dash is all the elements in the universal set which are not present in P. So P contains 0, 2, 4, 6, 8. So what are the elements here? 1, 3, 5, 7, and 9. Okay. 1, 2, 1, 3, 5, 7, and 9. What is Q dash? Q dash is all the elements in the universal set which are not present in Q. So let us see. Q is 1, 2, 3, 4, 5. So this is 0, 6, 7, 8, and 9. Now what is P dash intersection Q dash? I have to write down only the elements which are present in both P dash and Q dash. So which are the elements? So this 7 is an element which is present in both. 9 is an element which is present in both. So P dash intersection Q dash will be 7, 9. And can you see this is equal to this? So this is equal to P union Q, which is equal to P union Q complement. Okay. So the De Morgan laws is that P union Q complement is equal to P complement intersection Q complement. Okay. And same way I can also prove this second equation also. P intersection Q complement will be equal to P complement union Q complement. Okay. No, yes, if they have both have same elements, in A cross B it is different. Okay. A cross B I will have 2, 2. See, what you are asking is this, no? Suppose A is 2, 3 and B is 2, 3. Then A cross B will be what? First element with first element of B, first element with second element of B. So this is 2, 2, 2, 3, and then first element of second element of A and here. So 3, 2, and 3, 3. Okay. This is the cross. Okay. This is a Cartesian product. That is different. And when I'm writing union or intersection, that is different. Okay. Yes, I hope you've understood. Yes, Darshani. Little late, no problem. You can still do it. Yes, very good. Yes, Dimple. Mangilal. Yes. Now, a very important, again, formula that will help you to solve some is this. Okay, this is very important. N of A union B That is, how many elements are there in A union B? That is equal to n of A plus n of B minus n of A intersection B. Means what? If I want to find out how many elements are there in the union, I have to take all the elements of A and I have to add all the elements of B, and then I have to remove which are common elements. So that will give me the total number of elements that are present in A union B. Also, this property is also important. Okay. If A and B are disjoint set, means what? Let me show you. Okay. Suppose I have people who like tea, then I have people who like coffee. But aren't there so many people who like both tea and coffee? Yes. It's very cold, so I may be ready to drink whether tea is present or coffee is present. So I may be able to do that. Okay. Then this is coffee. So then what about these people? Just let me explain. Okay, this. Let me first color. Just bear with me. Okay. Now what I have tried to show you, this yellow stripes are there. Okay. What is these yellow stripes? Okay, you can see they are not going inside. These yellow means people who drink only tea. Okay. This yellow means these are people who drink only tea. Then what are the brown ones? They drink only coffee. Okay. These brown ones only drink coffee. And the green ones, they drink both tea and coffee. Okay. So they can drink tea or coffee. No problem. Now, when I have the universal set, okay, these are total number of people in the room, suppose. I am taking a survey of the people in the room. Okay. Or when guests come over, you know, what does your mother or father do? They will ask everybody in the room. Okay. क्या पियेंगे आप? Chai, coffee, you know, that they will ask you. So some will say tea, some will say coffee, some will say anything that is okay, anything. But then there will be some people who say, I don't want tea, coffee. Do you have any cold drink? No, I don't want tea and coffee. Okay, so that time, this thing which are outside this, okay, people who are outside this, okay. These people who are outside here, these are the people who are not going to drink tea or coffee. Okay. So these people, the pink, no tea or coffee. Okay. This is the concept that you must have in your mind. Then only you will be able to use this formula and do it. Okay. So what is here? So some people drink tea, some people will drink coffee, and some people will drink tea or coffee. Then there will be other people who will drink neither tea nor coffee. That is represented by the pink area. Now we are talking about disjoint set also. Now what is disjoint set? Disjoint set means when there is no relation between the between the two sets. For example, I want to say that A is a set of men, and then I would say B is a set of women. Then these are disjoint. There cannot be men who are women and women who are men. So these are the disjoint sets. So in that case, this intersection A intersection B, which are the common people who are both men and women, there are no. So in that case, this is equal to 0. Then for disjoint, this formula becomes N of A union B will be equal to N of A plus N of B. Is that clear? So this is what is meant by union, and this is what is the formula of A union B. Okay, where we are talking in terms of the numbers. So the formula is N of A union B. That is, how many elements will be there in A union B? It will be equal to N of A plus N of B, elements of A plus elements in B minus elements which are common to both. Okay. So in this case, whenever you get sums like this, so you will here have number of elements in A union B will be equal to yellow plus green plus brown. Okay, that will give you A union B. What will be the elements of A union B complement? It will be equal to 1 minus yellow plus green plus brown. Okay, I add this up. When I say subtracted from 1, I will get A union B complement. Okay, 1 or total number. Okay, whatever is given to me, which is equal to the pink. Okay, what will be the number of elements in A complement? A union B complement, it will be the elements present in pink. Okay, this can be 1 or this can be n. Okay, whatever total number is given of the universal space. Okay, so that will be. You can similarly do it for 3 sets. Okay, you can similarly do it for 3 sets. For 3 sets, let us have this A, this is P, this is Q, and then you have R. So in this case, what is happening is, this is representing, this blue is representing P intersection Q intersection R. These are the elements which are common to all 3 sets P, Q and R. Okay. Again, same thing with the disjoint. When there are 3 sets are disjoint, then you will not have the other elements. Now, what is the formula? N of P union Q union R is equal to N of P, that is number of elements in P, plus elements in Q plus elements in R minus elements which are common to P and Q, that is N of P intersection Q minus N of P intersection R minus N of Q intersection R. So all the 3 intersections I'll subtract, plus whatever is common, plus, this is important, plus N of P intersection Q intersection R. Okay. Hope you've understood this. Yes, Alpitanga, green is when they are liking both. Mahek, the diagrams will not come for drawing in the exam, but when you're solving the problem, sometimes just drawing the Venn diagram becomes easy for you to be able to calculate. Okay. Yes, very good. Yes, Savitri, good. Yes, Ashutosh, you got it? Good. Manish, we will do the sum and then you will see. So this is called as the Venn diagram. Okay, the name is Venn diagram. So here, what is this? Which of these is disjoint? Can anybody tell me? If this is diagram 1, this is diagram 2, diagram 3. Which of the diagrams 1, 2, 3 is a disjoint set? Anybody? Just put it in the chat box. Yes, Yashraj. Which of sets 1, 2, 3 is the disjoint? Oh wow, so many of you. Tanmeet, Arudhya, Surya, Siddharth, Aryan, Dimple, Anushka, Ritu, Alpithangal, Darshani, Anmol, Ankur. Okay. Ashutosh, please pay attention. When do we say it is disjoint? When there are no common elements. Here, these are common elements. So this is not disjoint. This is the disjoint because can you see there is no overlap? When there is no overlap, when we say it's a disjoint set. Now here, what will be the formula? N of A union B is equal to N of A plus N of B minus N of A intersection B. What is the formula for here? N of P union Q union R is equal to N of P plus N of Q plus N of R minus N of P intersection Q minus N of P intersection R minus N of Q intersection R plus N of P intersection Q intersection R. Okay. So this is what you must remember. Okay. They may even show you the diagrams and ask you which of them is disjoint. That also you will be able to do. If they give you the diagram and ask you to write down the formula, I mean write down means tick the correct option. So in that case also you will be able to do. Okay. Okay. So let us take a break and then we go on to the sums. Okay. This is the first sum. This sum is page 7.17. Okay. 7.17. These are the sums we'll be doing right now. And then we will go to the exercise also. Okay. So I will show you by both the methods, by solving it also and by Venn diagram also. Wherever that is possible, we will be doing that. When it is not possible, we will do whichever method is easy, we will be doing it that way. Okay. Vinu, break le le. Welcome back. Now let us go into this beautiful sums that we have. So this is on page 7.17. In out of a group of 20 teachers in a school, 10 teach mathematics, 9 teach physics, and 7 teach chemistry. Okay, 4 teach maths and physics, but none teach both maths and chemistry. Okay, this is important. None teach both maths and chemistry. How many teach chemistry and physics? How many teach only physics? Okay, this is specially important. I have specially chosen this because whenever I have sums like this, when I'm seeing, I either draw 2 circles for a Venn diagram or 3 circles. Okay, this is a bit unique. Okay, normally how do I draw? I draw like this, or if they are disjoint, I draw like this, or if there are 3 sets, I draw like this, right? This is what we usually do. But here, what are they saying? Out of a group of 20 teachers in a school, 10 teach mathematics, 9 teach physics, and 7 teach chemistry. 4 teach maths and physics, but none teach both maths and chemistry. So here, what is going to happen is, I can now see that there are teachers of which subject? Physics, which are teaching, out of them, some may teach even mathematics also. They are physics teachers, but some of them will also teach mathematics, and some of the physics teachers may be able to teach chemistry also. But there are no teachers who can teach both chemistry and mathematics. So in this case, this is going to look like this. Okay, this is the unique way. Okay, and that is purposefully I have taken this. This is my physics, this is my mathematics, and this is my chemistry. How many? 10 teach mathematics. So this is 10. N of P is equal to 10. How much is physics? Physics is equal to 9 and chemistry is equal to 7. 4 teach mathematics and physics. So mathematics and physics, how many are there? 4. None teach this. Now they're asking you this. How many teach physics and chemistry? And how many teach only physics? Okay. They were asking you to find out this portion. Okay, this pink portion they want you to find out. Okay, they are asking you, what is this? Okay, what is this? This is only physics. Okay. Now, what are the total number of teachers? Total number of teachers are 20. So, what do I have? What is my formula? N of P union Q union R is equal to N of P plus N of Q plus N of R minus N of P intersection Q minus N of P intersection R minus N of Q intersection R plus N of P intersection Q intersection R. Okay. So here what is happening is this is equal to, so 20 is equal to how much? Now out of this 10, 4 are 4 teachers. Out of the 10 mathematics teachers, there are some teachers, 4 teachers who are going to teach physics also. So how many only mathematics? 6. 10 minus 4, 6 is only maths. Okay. So only maths plus physics and maths. So total is 10 teachers. Okay. Chemistry is 7. And they are asking you this. Okay. So 20 is equal to N of P is 10 plus 9 plus 7 minus P intersection Q is 4 minus N of P intersection chemistry minus N of Q intersection R, that is maths intersection chemistry, I know is 0, and this intersection I also know is 0. There is no teacher who can teach who can teach physics, chemistry and mathematics. What does this mean? P intersection Q intersection R is those teachers who can teach all the 3 subjects, physics, chemistry, PCM. But that is not the case. So what I do, N of P intersection C is equal to, how much will this be? 10 plus 9 plus 7 is 26 minus 4 is 22 minus 20. Okay, this is 2. Okay, I take P intersection C to that side and then I solve this. So I get this is the number of teachers who teach both physics and chemistry. So instead of this, what am I going to write here? I found it to be equal to 2. Okay. Now they are asking you how many teach only physics. So this, how many teachers are there total who teach physics? 9. Out of them, 4 teach both physics and mathematics. 2 teach both chemistry and physics. So 9 this is 9 minus 4 minus 2, which is equal to, this is 6, so 3. There are 3 teachers who teach only physics. Okay, I hope you have understood. I have shown it to you in the diagrammatic form also, and I have shown you how to use the formula also so that you can get an idea. Yes, Manish, very good. See, Manish, you have understood. Mehak, Bhumi. See, no Dhruv. If the intersection is empty, does not mean, okay, if when an intersection is empty, then that set is a phi set, right? That is okay. But here, P intersection C is phi. But here, this is the format. You will have out of 20 teachers, okay, I will just summarize it over here so that anytime you get, so what does it mean? 6 teachers, only maths. 3 teachers, only physics. And this is 5. Okay. 7 minus 2. 7 minus 2 is 5. 5 teachers, only chemistry. Then I have 4 teachers, physics and maths. I have 2 teachers, physics and chemistry. 0 teachers, maths and chemistry. Okay. So this is how this sum is going to look. Please put it in the chat box whether you understood. Yes, Anushka. Yes. Understood, Baba sir? Yes, Ashutosh, it becomes easy on the diagram for you to understand. Tanmeet has understood. Dimple Manish has understood. Ankur, Aryan. Excellent. Excellent. Okay. Anushka, there were total number of teachers who were given, and then we have to find out how many teachers teach only physics. So in that case, what I have done is I've put it in the diagram also, and I've used the formula also. Why I'm doing both the things, so that I don't make a mistake, and so I have solved it and got the answer. Okay. Let us go to the next sum. A survey shows that 74% of the Indian like grapes, whereas 68% like bananas. What is the percentage of Indians that like both grapes and banana? Okay, here remember the trick is take total number of Indians to be equal to 100. Okay. Now, in simple sums, there will be no person who does not like grapes and banana. But sometimes you may get a question where that information is also given. But right now, such is not there. So let us take total number of Indians is 100. Okay, instead of writing in percentage. So I have okay. This is my grapes. Set of grapes. This is a set of people who like bananas. Now 74% of Indians like it. So if there are 100 Indians, 74 people are going to like grapes and 68 people are going to like bananas. But total number of people is 100. Okay, so I have the formula N of A union B is equal to N of A plus N of B minus N of A intersection B. Okay, I always say whenever you are learning new formula, always write down when you're practicing and speak it out aloud. Okay, now total number is 100. Number of people who like grapes is 74. Number of people who like bananas is 64. And I don't know how many people like grapes and bananas. So N of grapes intersection bananas. Okay. So N, I take this to this side. N of grapes intersection bananas is equal to 74 plus 64 or 68. Sorry. Minus 100. Okay, this 100 I take to this side, it becomes minus 100. This minus goes to this side, it becomes plus. So this is how much? 74 plus 68 minus 100, which is equal to 42. So 42. And so answer, you take 42%. Okay, remember, this is the answer. 42% of Indians like both grapes and bananas. Understood? Dhruv, in the earlier sum we found out without Venn diagram only we have found out, right? Here. You have to take the total number of students, total number of teachers of physics, and then from that, okay. Dhruv wants to know without Venn diagram, how do I do that? So see, here what did I find out? I found out, let me show it over here. N of physics is how much? 9. Okay, total number of physics teachers. This is total number of physics teachers. Okay. Then what is P intersection M? Physics teachers who also teach mathematics. This is 6. Right now, after calculation, we found out physics intersection chemistry. How many are there? 2. So how many? No, this is 4. Physics and mathematics, the number of teachers are 4. Physics and chemistry, number of teachers from formula we found out 9. So out of 2, out of the total 9 teachers, when I subtract this 4 minus 2, how much is this? 9 minus 4 minus 2, this is also equal to 3. So without Venn diagram also you can calculate, this is only physics. Okay. That is only for your understanding. Even just by the formula also you will be able to do it. Understood, Dhruv? Now let us see. In a class of 60 students, 40 students like maths, 36 like science, 24 like both the subjects. Find the number of students who like maths only, science only, either maths or science, neither maths or science. Okay. So, which is very typical, right? There are so many students, especially when you were in 10th standard, what was happening? This is my classroom. Okay. How many students are there in my classroom? 60 students, right? Then you know those sciencey students who used to love maths and science in your class 10. Okay, so this is my maths, this is my science. Okay, so first is they're asking you to find only maths. Okay, so if I'm doing this, okay, this is what they are asking you to find out. Only maths. Then they're asking you to find out only science. And then third, either maths or science. Okay, so that is all these three: pink, white and blue. Okay, and neither maths nor science. Okay, this is the remaining portion here. Okay, this is too much to color, so I'll just leave it at that. Okay. So I'm going to write it over. Maths only pink color. Okay, science only this blue colored. They want you to find either maths or science is pink plus white plus blue. Okay, neither maths nor science is yellow. Okay, this is does not look good. Let me write it again. This is blue. Okay, this is what they have asked us to find out. Okay, now this A union B, that is maths or this thing. So n of maths union science is equal to n of maths plus n of science minus n of maths intersection science. So 40 students. Here I've forgotten to write. This M is 40, S is 36, and 24 like both maths and science. So M union S, that is number of students who like either maths or science or both, is equal to 40 plus 36 minus 24. This is equal to how much? 76 minus 24. This is equal to 52. Okay. So this is for answer for the third one. Okay. This is for third one. So how many students are there who like either maths or science or both? There are 52 students. So yellow, I want to find out, that is don't like maths or science. Okay, so this is equal to how many total number of students are there? 60 minus 52. So there are 8 students who don't like either maths, don't like neither maths nor science. Okay, now only science, that is the blue portion. How much will that be? 36 minus. So second, only science is how much? That is, there are 36 students who like science. Out of that, 24 like maths and science. So how much do they get? 12 are the students who like only science. Okay. Maths only the pink portion. Okay. First, maths only. So only maths is equal to 40 minus 24, which is equal to 16 students are there who like only maths. Is that clear? Yes, Ankur, 16, 12 and 8. Yes, 52. Yeah, correct, Ritu, Darshini, Ankur, Bhumi. Yes, very simple. Yes, Dhruv, very good. Now let us go to exercise 7A. Okay, let us do it a little faster. I don't know, there's given only one lecture for the big chapter on sets, relation and functions. So I will do this much. Okay. And try as many sums, and then we'll go to, in 10 minutes time, we'll go to set relations and functions. I'll try to explain that and then come back here to solve as many problems as possible. Okay. And I will try to show you all the solved explanation to the examples of the, not example, of the exercise. The number of subsets of the set 2, 3, 5. You know that number of subsets is given by 2 raised to n. What is n? N is a number 1, 2, 3. So there are 3 elements. N is total number of elements. So 2 raised to 3, which is equal to 8. Okay. Quickly we are doing. The number of subsets of a set containing n elements is given by 2 raised to n. The null set is represented by this. See, this is not the correct answer. This is not the correct answer. Only this. Then next is A and B is given, A intersection B. All elements which are common to A and B. Is 2 here? No. 3? No. 5? No. 7? No. So this is the correct answer. A intersection B, it is a null set because there are no common elements between A and B. The set X is such that 0 less than x less than 5 represent the set where x may take only integral value. This is important. Integral means you don't have decimal 1.5. That is not there. Now, see, 0 less than x less than 5. It is not. This is different and this is different. Okay. This is given by this 1, 2, 3, 4 because it has to be greater than 0 and less than 5. So 1, 2, 3, 4. And those are only integral value. This is for what? 0 less than, and this is not even this. This is 0 less than or equal to x less than or equal to 5. Then this is the condition. Here this is 0 less than x less than 5. Okay. This will be what? 1 less than or equal to x less than or equal to 5. Or you can have 0 x greater than 0 less than or equal to 5. Then this is the way you have to write it. Okay. The set 0, 2, 4, 6, 8, 10 can be written as. Okay. What are these? These are even numbers. Okay. These are even numbers. So 2x is such that now this is less than. So this is not the answer. This is also not because this is x is e. So this is also not. 2x is 0 less than or equal to x less than or equal to 5. So this will be your correct answer. Okay. Now what is the cardinal number? The 7th sum. Cardinal number of P intersection Q. I think it is following an earlier sum. Do we have P and Q sum? No, I think we can't solve this because I don't have the sum given. I've forgotten to write the sum here. Okay. The set of cubes of natural numbers is an infinite set. Okay. This is the kind of theory they may ask you. Okay, set of cubes of natural numbers. How many natural numbers are there? There are infinite. So their cubes will also be infinite. Okay. Now 13th sum. This is from which exercise? Yes. Now 1 for all integral x. Okay. Now what will happen if I put x is equal to 1? Okay. If I put x is equal to 1, what will happen? 1 minus 1 minus 1 raised to 1. Minus 1 raised to 1 is same thing, 1 minus of minus 1, which is equal to minus into minus is plus, so 1 plus 1, answer is 2. Let me put x is equal to 2. So 1 minus 1 raised to 2. So minus 1 square will be plus 1. So this is 1 minus 1, answer is 0. X is equal to 3. So 1 minus 1 raised to 3. So minus 1 raised to 3 is minus 1. So 1 minus 1. So which is equal to 2. So, and if I carry on, then this is the correct answer. So answer will always toggle between 0 and 2. E is a set of positive even numbers and O is a set of positive odd numbers. Then E union O will be the set of the natural numbers. Okay. It is a set of all natural numbers. Because E is a set of positive even numbers, that is 2, 4, 6, 8, 10. O is a set of all positive odd numbers, that is 1, 3, 5, 7. So this will be the answer. If R is a set of positive rational numbers and E is a set of real numbers, then R is a subset of E, right? So R is a subset of E, and is it a proper subset? Yes, it is a proper subset. So B will be the correct answer. If N is a set of natural numbers and I is a set of positive integers, then I will be a I is a set of positive integers. So what will they be? Are they different? No. I is set of positive numbers. It is not saying only integers. So because integers may be negative also, but natural numbers, you know, are only positive. So that means A is equal to N is equal to I. Okay. All natural number, all positive integers are natural numbers. If I is a set of isosceles triangles, if I is a set of isosceles triangles and E is a set of equilateral triangles, then equilateral triangles is a special case of isosceles triangles. Okay. Equilateral triangles is a special case of isosceles triangle. What is isosceles triangle? Okay. When two sides are equal. And what is an equilateral triangle? When all sides are equal. Okay. So this is a special case. Here only two sides are same. Two sides are equal. Here all three sides are equal. Okay. So this is a special case of this. So E is a subset of I. Okay. E is a subset of I. Okay. Now let us take this sum. E is 1 to 9. The subset E satisfying the equation 5 plus x greater than 10. So when will that happen? 5 plus 5, I know that 5 plus 5 is equal to 10, but the answer is, the question is talking about greater than. So it should be, and this here you can see there are all integers. So this is 5 plus 6 will be equal to 11, 5 plus 7 is equal to 12, 5 plus 8 is equal to 13, 5 plus 9 is equal to 14. So the subset of E that is satisfying this equation is what? 6, 7, 8, 9. So B will be the correct answer. Okay, so B will be the correct answer. Okay, let me first do this. Let me do this. Okay, this is one example I'll take, and then we'll move to relations and functions. A sample of income group of 1172 families was surveyed and noticed that for income groups, there are 4 income groups: less than 6,000, 6,000 to 10,999, 11,000 to 15,999, and above 16,000. These are the salary groups. Okay, and then they have surveyed these families and tried to see how many TVs the families have. So, how many families have no TV? No TV, 70, 50, 20, and 50. 70, 50, 20, and 50. How many have one TV? How many have one TV? 70, 50, 20. One set is available to 152, 308, 114, and 46. 152, 308, 114, 46. And 2 or more sets, 2 or more. How many? 10, 174, 84, and 94. Let us check whether the total comes to 1172. 70 plus 50 plus 20 plus 50. This is equal to 70 plus 50 plus 20 plus 50. This is 190. Then 152 plus 308 plus 114 plus 46. This is 620. Then 10 plus 174 plus 84 plus 94. That is 362. 362 plus 620 plus 190 is 1172. Okay. Okay. This is how you should write it down. Once you've written it down like this, it becomes very easy. Even though it is looking such a big thing, it is not a big sum. It is just a way in which you have to rearrange the things. Now, A is a set, the family owning 2 or more TV sets. So, which is this? Okay. Which of this is this? This is A. B is a set with 1 TV set. This is B. And C is a family with income less than 6,000. This is C. D is a family with income 6,000 to 1099. So this is D. E is a family with income 11,000 to 15,000. So this is E. Okay. So once you have made this matrix, it becomes very easy. Okay. Find the number of families in each of the following. C intersection B. So C intersection B. This is C intersection B. Okay. So C intersection B. Then A union E. A union E. Okay. So this becomes very easy for you to do that. Now what is the set A? A set is total is 362. Now I have to find the total of E. This is 20 plus 114 plus 84. That is 218. Okay. Now they are asking you A union E. So 218 plus 362 minus what is the common? 84. 496. So 152 and 496. How did I get that? C intersection B, very easy. This is directly you can get from here. Okay. Now for A union E, what do? I will use the formula. This is equal to N of A plus N of E minus N of A intersection E. Okay. What is this representing? This is representing C intersection B. What is this 84 representing? It is representing A intersection E. So A union E. What is N of A? How many families are there with 2 or more TVs? 362. Okay, this is given to us. 362 plus N of E is how much? I found the total 20, 114, 84. So I found it. It is 218. How many are there with whose income is lying between 11,000 to 15,999 and they have 2 TV sets? 84 minus 84. This is giving you 496. Is that clear to you? Yes? Okay. Yes, Ritu, I have shown all the numbers. Okay. So you have to do it this way. Yes, understood? Good. Good. Okay. So just draw this, use your concept that you have learned, and then you will be able to find the answer. Okay, let us go to the concepts of relation and function. Relation and function. Any subset of the product set X into Y is said to define a relation from X to Y, and any relation from X to Y in which no two different ordered pairs have the same first element is called as a function. So, in this sentence only you will know what is the difference between relation and function. Okay. When no two different ordered pairs have the same first element, it is called as a function. Okay. So that suppose I have 1, 2 and I have 3, 4. If I'm writing this is a function. But if I have 1, 2 and 3, 4, then 1 is also to 3 and 1 is also this relation to 4, then it is not a function. This is a function, this is not a function. Let A and B be two non-empty sets, then a rule or correspondence F which associates each element of X of A to a unique element denoted by Fx of B, it is called as a function. So how do I represent it? I represent it by this, okay, like this. Or when I'm trying to write it down, I say there is a function which goes from A to B, okay. Or when I apply this function on the elements of A, I will get some numbers or some elements in B. Okay. So when I use this function and apply it on the elements of A, the answers will be found in B. Okay. The element fx of B is called as the image of X. Okay. So what do I say? X and image of X. Okay. Elements of X. This I call pre-image and this I called as image. Okay. So X is called as image and X is called as pre-image and Fx is called as image. X is pre-image and Fx is image. All the elements of set A are called as domain. All the elements of set A are called as domain. All the elements of set B are called as codomain, and all the elements which satisfy the given function are, that is called as range. Okay, that is called as range. So I have domain, I have codomain, and I have range. Suppose I have this 1, 2, and 3, and my function is squares. Okay, squares. And here this is my set A. And I have a set B. 1, 4, 9, 16. Okay. Then what happens? This is my domain. This is my codomain. Now I want to map this function. What is the function? Function is saying square. Okay, what is my function? Fx? Fx is x square. Then what do I do is, what is the square of 1? It is 1. What is the square of 2? It is 2. What is the square of 3? It is 9. Now what happens is, there is still the 16. Does it have an image, pre-image here? No, it does not. Then I say that the range is equal to 1, 4, 9. Okay. All the answers which satisfies the function fx is equal to whatever the given function. In this case, it is x square. So that is called as the range. Sometimes you may have codomain will be equal to range. Suppose I have A and I have C. This is 1, 2, 3 and this is 1, 4, 9. So 1 mapping to 1, 2 mapping to 4 and 3 mapping to here. So here in this case codomain is equal to range because there are no elements in C which do not have a pre-image in A. Okay. Is that clear? Yes, clear. Good. Alpit Uncle? No, domain, there is no difference between domain and codomain. There are two different things. Domain means the elements on which the function is going to be applied. And what is codomain? Codomain is the set which contains the answers to this function. Okay. And what is range? Range is the elements which satisfies the given function. So domain is A, codomain is B, and range will be all the elements which satisfy the given function. Okay. Yes, Manish understood, Ritu understood, Tanmeet, good, Mangilal. Okay, Ankur, simple calculators are allowed where you have square root or percentage, that is allowed. Okay. Pramod, yes, very good, Pramod, you've understood. Then 1 function, how do I write this? I write this as A function goes from A to B. If different elements in A have different images in B, then F is said to be 1, 1 or it is called as injective. Okay, it is called as injective. If different elements of A have different images in B, then F is said to be injective function or also called as mapping. Onto or surjective. If F is such that every element of B has at least one pre-image in A, then F is said to be an onto function. Okay, I will show with the example also. If F is onto, then corresponding to each Y which belongs to B, we must be able to find at least one element in A, which is Y is equal to Fx. If F is onto, if and only if range of B is equal to, range of F is equal to B. That is, your codomain and range should be same. Only then you will be able to have an onto function. Bijective function. If 1, 1 and onto function is said to be bijective. Bi means 2. What are the two conditions that are being satisfied? That it is 1, 1. And also it is onto. Means what? Every element in B has a pre-image in A. Okay. Bijective means every element in B has a pre-image in A, and 1, 1 means every element in A has a distinct image in B. Every element in A has a distinct image in B. When these two conditions are satisfied, you say that the given function is a bijective. Identity function. If A is non-empty set, then this is your identity function. Okay. Identity function is, this is also a good popular theory question. It is a 1, 1 onto function with domain A and range A. Identity function is a 1, 1 function onto function with domain A and range A. Then we have talked about injective, bijective, surjective. Okay, and now we are talking about into function. There exists even a single element in B having no pre-image in A, then F is set to a inject into function. Okay. So as we talked here, 1, 2, 3, and I have 1, 4, 9. Then I have 1, 2, 3, and I have 1, 4, 9, 16. Okay. We have taken this example earlier. Now this is a onto. Why? Because 1 square is 4, 2 square is 1 square is 1, 2 square is 4, 3 square is 9. And here 1 square is 1, 2 square is 4, 3 square is 9. But there is 16. There is this element 16 which does not have a square root in the given function. Okay, given set. So this is onto and this is into. There is at least single element in B which does not have a pre-image. Okay, this is 1, 2, 3, and here I am showing you 1, 4, 9, and 16. Okay, so I can see here that my relation is there. 1 square is 1, 2 square is 4, 3 square is 9, but this 16 is there which has no pre-image. So this is an into function. Constant function is defined in such a way that all the elements in A have the same image in B. Then it is a constant function. For example, I have -2 and 2 is my set A. Then I have 4. When I'm saying square, my function is what? Square. Square of -2 is how much? 4. What is the square of +2? It is also 4. So this. So all elements in A have the same image in B. Then it is said to be a constant function. Equal functions, two functions F and G are said to be equal and they are written as this. Okay. If they have the same domain. Okay. Inverse function. When this is a theory question also. If F is a 1, 1 onto function, only then you can find its inverse. I repeat, please pay attention. If your function is 1, 1 and onto, only then you can find a inverse. Okay. When we do the sums, you can see it, but this is a good theory question. So a function is invertible if and only, inverse, or it is also called as invertible if and only if it is a 1, 1 and onto. Okay. This is 1, 1. Okay. This is 1, 1. And this is known as many 1. Okay. Because many elements of A have the same image in B. This is called as many 1. Okay, now let us talk about relations. There are 3 types of relations that we are going to talk about, and then, yes, Darshini, very good. Thank you, Ritu. Thank you, Darshini. It's so nice to know that you've understood. Yes. 1 to 1 is what? Every element of A has a unique image in B, then it is 1 to 1. Okay. When it is not that way, you say it is many 1. Now let us talk about relations. You have reflexive, you have symmetric, and you have transitive. And then when your relations satisfy all these 3, then you say it is an equivalent relation. When it satisfies all 3, it is called as okay. So I have a set A, B, C, D, E, and R is a subset of the product set SS, S cross S. So R contains all ordered pairs of the form AA. Now let us see. Let me write down S cross S. First element I take A, and then, so this is AA, this is AB, this is BC, and so on. Then I will take BA, BB, BC, and so on. Okay, the S cross S will look like this. Now, if R contains all ordered pairs of the form AA, means what? Both are same. Then R is called reflexive. So here what will happen? I have this AA, BB, then I will have CC. Those are all reflexive. That is reflection. If I look into the mirror, who is going to look back at me? Myself. Okay. So that is called as reflexive. So is equal to is an reflexive relation. So when I write 5 is equal to 5, so this 5 is equal to 5, and if I go from this direction also 5 will be equal to 5, right? There is no difference. Now if AB belongs to R and BA also belongs to R, for every AB belonging to S, then R is called as symmetric. So for example, in this case, this is AB and this is BA. Okay, then we say that it is symmetric. Okay, then we say it is symmetric. So A is equal to B means B is equal to A. Suppose I'm talking of parallel lines. Suppose this line is A and this line is B. If I say A is parallel to B, doesn't it mean that B is also parallel to A? So that is called as symmetric. Third is called as transitive. If AB belongs to R and BC belongs to R, it implies that AC also belongs to R. Then it is, you say that the relation is transitive. Okay. So AB, BC and AC. Then we say that it is transitive. Okay, a relation which is reflexive, symmetric, and transitive is called as the equivalence relation, or simply called as equivalence. Okay. For example, we are talking about the parallel lines, or the set of all parallel lines in the plane are symmetric. Okay, are equivalent. So I have, this is my line A. This is my line B. And this is my line C. Now, is A parallel to itself? Yes. So, it is reflexive. Now, A is parallel to B. Does it mean B is parallel to A? A? Yes. So, it is symmetric. A is parallel to B and B is parallel to C. Does it mean A is parallel to C? Remember class 10? We have studied in geometry. When two sets of lines are parallel, obviously the third line will also be parallel. So A parallel to B, B parallel to C, A parallel to B, and B parallel to C. Doesn't it imply A is also parallel to C? So that means it is transitive also. So it is reflexive, symmetric, and transitive. So we say that is parallel to is a equivalent. Understood, Ritu? Okay. Mangilal? Yes. So if you understood, please in the YouTube also put yes, and here also you can put yes. Just let me know you've understood. Okay. Just press the like button on YouTube, and here you can put it in the chat box whether or not you have understood, so that I can know. Yeah, very good, very good. Bhumi, Ankur, Tanvi, Dimple, Darshini. Yes? Okay. Just let me show you instead of this. Let me share something else. Let me, yeah. Okay, this is exercise 7C is smaller than over the set of x. Whether it is, now I have this 1x, then this x, and then this x. Okay, is the x smaller than itself? Is 1x smaller than itself? No. So is it reflective? It is not reflective. Is it symmetric? And whether it is transitive. Okay, is smaller than. If I'm saying this egg A is smaller than B, does it mean B is smaller than A? No. If A is smaller than B, B is bigger than A. Obviously, so it's not symmetric. So is it transitive? A is smaller than B, A is smaller than C, then automatically A will be smaller than C. A is smaller than B, B is smaller than C, then automatically A will be smaller than C. So this is transitive. So is smaller than, this relation is a transitive relation. Is equal to is equivalent. Okay. So if when I'm saying 5 is equal to 5, is 5 equal to 5? Yes. So it is reflective. If this 5 is equal to this 5, does it mean this 5 is equal to this 5? Yes, it does. So that, let me show it by, this is 5 is equal to, okay. Is the blue 5 equal to itself? Yes. Is the blue 5 equal to red 5 and the red 5 equal to blue 5? Yes. And can I write it like this? This 5 is equal to this 5, this 5 is equal to this 5. Yes, so it is an equivalent. Okay. Is perpendicular. Okay. If I'm drawing this lines like this, I'm saying line A is perpendicular to B, then it also means B is perpendicular to A. Okay. When I say is reciprocal of over a set of non-zero numbers, then it is symmetric. If I say 5 is the reciprocal of 1 upon 5, then 1 upon 5 is also the reciprocal of 5. Now x, y is such that x belongs to x, y belongs to, and y is equal to x. What is the relation? Y is equal to x. It is equivalence. Equal to means it's an equivalent. Now I have x plus y is equal to 2x. Okay. In question number 7, x plus y is equal to 2x. I take this plus x to this side. It becomes y is equal to 2x minus x, which is equal to x. So y is equal to x. It's an equivalent. Is the square of over n set of real numbers. Is the square of. So I have A is equal to, say, suppose 2, 3, and I have B to be equal to 4, 9. When I say 2 is a 4 is a square of 2, does it mean 2 is a square of 4? No. So it is not symmetric. Is the number square of itself? Is 2 a square of 2 itself? No. So it is neither reflexive neither symmetric. If I say 2 is a square, if I say 4 is the square of 2 and 16 is a square of 4, does it mean that 16 is a square of 2? If I say 4 is the square of 2 and 16 is the square of 4, does it mean 16 is the square of 2? No. So it is neither transitive. So A square of is neither reflexive nor symmetric nor transitive. So none of these will be the answer. Okay. These 9th and 10th you can do that. 11th also is equal to, this is 3 elements are there, 2 raised to n, which is equal to 2 raised to 3, which is equal to 8. Okay. This is important. I've specially marked it also. See, v is x is such that x plus 2 is 0. So for v, what is the function? X plus 2 is equal to 0. For r, what is the function? X square plus 2x is equal to 0. And what is the function for s? X square plus x plus minus 2 is equal to 0. Okay. Now I solve this quadratic. X square plus x minus 2 is equal to 0. So what will I get? X plus 2 and x minus 1, right? You know how to solve the quadratic, is equal to 0. So what can be the value of x? X can be minus 2 or x can be plus 1. Okay. X can be minus 2, x can be plus 1. I put it in this equation for v and for r. What will happen if I put it in the equation for v? X plus 2 on the LHS. So if I use minus 2 plus 2, answer is 0, which is equal to the RHS. For r, x square plus 2x. X square is how much? Minus 2. Minus 2 square is plus 4. And this is minus 4. Plus 4 minus 4, answer is 0. And S answer is 0. So minus 2 is satisfying. Now let me put x is equal to 1 and see. Let me put x is equal to 1. So 1 minus 1 plus 2, which is equal to 3, which is not equal to 0. So the first condition for v is not satisfied. So between these two numbers, x is equal to minus 2 and x is equal to 1, which is the number which satisfied? So minus 2. So the answer for 12th is this. Okay. So this is a unique sum where you got two answers, minus 2 and 1, but out of them only one is satisfying all the three sets, V, R and S. So we are taking this. Is it clear? Okay, this 17. This type of sums are very popular. A is 1, 2, 3, 5, 7. B is this. What is the A minus B? What are the elements of A minus B? Elements in A which are not present in B. Is 1 present in B? Yes. So I cancel that. 2 not present. So I'll write it here. 3, yes, it is present. I cancel. 5 not. And 7 is not. So what is A minus B? 2, 5, 7. And what is the cardinal number? How many elements are there? 1, 2, 3. So 3 will be the correct answer. Now 18 sum. Which of them is a graph? Can you see, suppose x is equal to 1 here. What is the value of fx? When do we say it's a function? When there is only one unique answer. Here for x is equal to 1, y can be equal to this, y can be equal to this, or y can be equal to this. So this is not a function. Now here, x is equal to 0, x is equal to 1. You can see everywhere the answer is different. Okay, so this is a function. This is correct. Now over here, let us consider this point. Suppose x here. If I draw a line, do I get unique? No, I get this is also one answer and this is also one answer. This is also y1 and this will be y2. So not a function. So this is not a function. Same thing over here. What happens? For here, one value is this, one value is this. So this is not a function. Okay. Okay, this is one thing that I want to do. If f of x g of x and f of g of x. Okay. What does this mean, g of f? G of f. So that wherever you have x, you are going to use this function. Okay. x square, g of f. That is, instead of x, you are going to write this function. So, g of x will be x plus 3 the whole square. Okay. So, x plus 3. So, instead of x, what am I going to write? X plus 3. And what is the function? Square. So, x plus 3 square. What will be f of g? Okay. Can you tell me what will be f of g? Can anybody put in the chat box? What will be f of g? Yes, Ayushi? Crystal clear? Good. What is f of g? Can anybody tell me here? So, in the function of g, I will write the function of f. And so, here, instead of here, what is the function of f? It is x plus 3. So, here I am going to write it. So, I want you to write the answer here. What will be f of g? Now, this is important, finding the inverse. Okay. So, here I'll show you the inverse also. I want you to tell me the answer of f of g. Now, what is your fx? Fx is equal to 1 upon 1 minus x. Okay. So, what I do is, this is equal to y. Y is equal to 1 upon 1 minus x. So, what will this be? 1 minus x is equal to 1 upon y. 1 minus x is equal to 1 upon y. So, x is equal to 1 minus y. 1 minus 1 upon y. Okay, I take x to one side and I take 1 upon y to another side. Okay. So, minus x becomes plus x and 1 upon y plus 1 upon y becomes minus x. So, this is equal to y minus 1 upon y. Okay, y minus 1 upon y. I replace y with x. I replace y with x. So, what is this? Inverse is equal to x minus 1 upon x. Instead of y, I am writing x. So, x minus 1 upon x. So, this is a unique way in which you solve the inverse. Okay. F of g. Yes, can anybody tell me the answer? X square plus 3. Rudra? Arudhya? Okay. F of g, what is it? It is x plus 3 the whole square. Okay. X plus 3 the whole square. So, instead of g, what did we do in g of f? See, what is the function f? F is x plus 3. What is the function of g? G is x square. So, in x square, what am I writing? I am writing the function f. So, this is my function. Now, what is the function f? F is x plus 3. Instead of x, what do I write? I write it x square. So, here it is x square plus 3. Okay. So, where you have this g of f and x square. Okay. Oh, we have already shot over the time. So, just, okay, here. So, just remember what are the different types of relation? Is reflexive, symmetric, and transitive. And any relation which satisfies all the three are called as equivalence relation. Okay. Yes. That's all for today. Thank you all for your patient hearing and have a great day ahead and have a great year ahead. All those who are giving the exam this year in June 2023, all the very best. And yes, Anushka, Happy New Year to you also. Bharat, Siddharth. Yeah, very good. Okay. Dimple, inverse you want me to explain? Okay. Just write whatever function is given to you as equal to y. Okay, just write it equal to y, and then solve it so that you get x on the left hand side. Then replace the y with x. What answer you get on the right hand side will be your inverse. Okay. Yes, Bhumi. Bye. Have a great day. Year ahead. Aisha, Pramod, Bhumi, Ritu, Surya, Sri Darshani, Ritu. Yes. Siddharth, Dimple. Yes. All the very, very best to all of you. Have a great year ahead. Thank you. Vinu?